Yeah, that was great. Okay. So we've just spent a couple minutes talking about math and how important it is in science. And we're going to go over a couple of things that you will need to know moving forward. And one is just about expressing quantities. Remember, quantity is anything with a number. So when you make an observation in science, you have anything with numbers, which we just called what kind of observation? Quantitative. And without numbers?
Qualitative.
Qualitative. So when you're going to measure quantity, you will often have two parts. The first part is a description of the size or the number of something. Anyone know what we call that? That's called a magnitude. And a magnitude means how big something is. Think of it like a magnitude of an earthquake. A magnitude 5 earthquake represents how big it is. And most numbers, not necessarily every number, but most numbers will have something else. Because if I just say, how far away do you live from the school? And I say 2. 2 what? What else do we need? So we need a magnitude and a unit. Anyone think of an example where an observation might have no units? Just think of one example.
Like the amount of something, like 2 chairs.
Yeah, that's what I said, one example. One marker, 2 chairs. We've got 24 people in the class. Those are just numbers. You're counting something. And there are a few other numbers that we see. I don't think many in this course, but there are some that we'll see that don't have units as well. But most will. And it's extremely important to include that unit when you're doing any kind of calculation. So often when we record something, there's more than one way to record it. We can use different units, or we can write the numbers in different ways. The unit thing I found interesting. Maybe this is a timely conversation. So I've been overseas once. I went to Britain, went to Ireland, ended up in Scotland. All probably about 16 years ago now. And I remember going to buy a bottle of juice, of all things. Click. And this is not necessarily the juice that I was buying.
What kind of juice?
It's a tropical juice. It's a blend of different fruits. Here's the thing that I wanted to point out, though. What's that? Centiliters. Right? We don't buy things in centiliters here. We buy them in milliliters. So if I'm looking at this thing, I'm ordering my groceries online. I'm going to pick them up and bring them back to the hotel, and I'm like, 200 centiliters. Huh? Is that a lot? It's what's that? 0.52 euros. I have no idea where this is from. I think it's French. Anyway, so how much am I getting for my approximately like 80 cents Canadian? What am I getting for that? So normally when we buy juice, we're buying it in milliliters. So how many milliliters? Yeah, 200. So I mean that's a pretty quick calculation. If you know what a centiliter is and you know what a milliliter is, you can do that calculation really quickly. And that's our goal, is to be able to do that with a variety of different units. So the unit one probably makes sense. But what do we mean when we say that we're going to write it a different way? I mean, you take a number, let's 500. How many ways can you write 500? It's a 5 and 2 zeros, is it not? So what are we really talking about there?
How else can I write 500? In I think it's written form, standard form.
Oh, like FIVE, space, and yeah, sure, we could do that. Generally, we try not to in science. That gets pretty cumbersome. Yeah, so exponents. So what we're talking about there is scientific notation. So right there, it's a mathematical concept that's named after science. It's written scientific notation. So it's always a number between 1 and 10, not including 10, and multiplied by some power of 10. So a few common examples that I have here. Speed of light, which we'll be talking about in this unit. 3.00 times 10 to the 8 meters per second. An astronomical unit, which you might have talked about in astronomy last year. Avogadro's number, which if you take senior chemistry, you'll be talking about that. An atomic mass unit, which would come up in maybe both chemistry and physics. So they're all numbers that are commonly written in scientific notation. So how do you go about moving one way from one style to the other? Because sometimes you want to put things into scientific notation. Sometimes you want to take things out of scientific notation. So how do you do that? Remember that when you multiply something by 10, it drives me nuts when I ask somebody to multiply by 10 and they pull out their calculator. Because when you're multiplying by 10, what are you really doing? If I take the number 16 and multiply it by 10, add a 0. You're moving the decimal place. You're moving the decimal place one time. You're going from there to there, and you got to put a 0 in to keep the place. Okay, so every time you multiply by 10, you move the decimal place. If I were to divide by 10, I'd move the decimal place the other way. So if I were then to multiply by 10 to the n, where n is some integer, it means that I'm going to move that decimal place n times. What that really means is that you're going to, if you're multiplying by a power of 10 to the n, you're just going to move that decimal place n times. If the number is positive, if it's like 1.6 times 10 to the 3, then we're going to have to move the decimal to the right, because we have to make the number bigger. 10 to the 3 is a large number, it's 1,000. So we have to move the decimal to the right if n is positive. If n is negative, 1.6 times 10 to the negative 3, well, that's like dividing by 10 to the power of n. It's like dividing by 10 to the 3. So you're going to move your decimal the other way. 1, 2, 3. Put the decimal there, fill in the zeros. Very important here, always have a number before the decimal. Never start a number with a decimal. So what number do I put there? 0. So the 0.0016. So you move the decimal to the left. You should have already seen this in grade 9. But I know from what I see in grade 11 and possibly even in grade 12 that it doesn't tend to stick very much, so we're going to do it again. And we'll do it again and again and again and again until we get it. So you're just moving the decimal. So what I want you to do right now, very quickly, is go up and try writing those numbers that are here in your examples in standard form. A suggestion to you, really important, if you're going to write a huge number in standard form, every third digit after the decimal, leave a space. So for example, 0.000 space, 000 space. So try with each one of those numbers to write out the number in standard form, in long form. And for those of you watching on the video, you just come back to this. Try it and then pause, try it, and come back. Okay, so check your answers with what I have here. We're going to see the benefit of putting those little spaces in, and there's no way that you would ever really want to write down like an atomic mass unit in standard form. You just wouldn't do it. It's one of the reasons that we use scientific notation, so we don't have to do that. But a number like 3 times 10 to the 8 might be one that you are that you would possibly want to write down. I would suggest using scientific notation anytime you get above, say, 10 to the 6 or 10 to the negative 6. But if you did want to put this out in long form, you can. So when putting the little gaps in between the zeros, like here and here, just means that now instead of counting all the zeros, you count the groups of zeros. So I got 2 groups of zeros. That's 2 times 3 is 6 zeros. And then I got another 2 over there, 7, 8. So I've got my 8 zeros. So another way to look at this is the 3 times 10 to the 1, the 3 would be here. So that's 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8. So we do that for all of them. And as you can see, it gets pretty messy once those powers of 10 become large. Now going the other way around, this might be a little bit more practical. Taking a number that's already in standard form and putting it into scientific notation. You just do the opposite. Okay, now you're moving the decimal and you're counting how many powers of 10. If you want to know whether your power of 10 should be positive or negative, if the number is greater than 1, then it's positive. If it's between 0 and 1, then the exponent is negative. So take a second and try those six examples, and we'll come back and see how you did. Just to go through an example on the first one to make sure you're on the right track. Your decimal, if you don't see decimal, it's at the end of your number. So over here in 1979, it's at the end, so you go back 1, 2, 3. So you go 1, what am I left with? 1.979 times 10 to the 3. We know it's positive 3 because the number is greater than 1. Similarly, decimal moves back 1 spot. You get 1.06 times 10 to the 1. Quite often, there are reasons why you would want to write this in scientific notation. And there are the answers that kind of round out the last part. Notice the last 2 on the right-hand column have a different number of zeros, and we will discuss this on the next slide.